I've got this BK Precision 2120 oscilloscope. I got this a few years ago on Craigslist, and all of a sudden the sweep has stopped working. So it seems like it's trying to sweep, but only goes less than one division, and actually seems to be sweeping in the wrong direction. We try the vertical here. Plenty of vertical deflection. But if we switch to XY mode here, put it on the same sensitivity, there's hardly any deflection. So I think it's probably not in the sweep generator circuits. It must be something in the horizontal sweep output circuit, or maybe the power supply to it. So let's take this apart and see what's happening. So it looks like it comes apart pretty easily. There's just 4 screws on the bottom here. And 2 more screws in the back here. Okay, well, we're in. And also I found online a complete service manual with complete schematic of the whole unit. And turns out all the sweep stuff is right here on the top circuit board, so it might stand a chance of actually doing some troubleshooting here. Okay, and just a little tour here back in the back there. There's the big old 60 hertz power transformer, none of this switch mode rubbish. There's rectifiers and the filter capacitors for the power supply. This is all power supply regulation. Up here is the horizontal sweep circuitry feeding into these power transistors, or the horizontal output. And then back here is the 2 kilovolt supply for the CRT. And looks like the vertical stuff is all down on the lower circuit board. So here's the final horizontal sweep circuit, push-pull transistors, and it's powered by a 260 volt line which comes from this power supply. So the power supply is actually 2 linear DC power supplies in series, 140 volt supply and then 120 volt supply for the total of 260 volts. This goes to the vertical output amplifier. This goes to the horizontal output amplifier. So I think the first thing is to just see if we have this 260 volts power on the horizontal output. So let's turn it on. .600 volt scale. So there's test points even marked here. It's really nice. Every component on the board is clearly marked here. So this is the 140 volt test point. Looks good. And here's the 260 volt point. Well, it's reading 24 volts. So clearly something wrong with the high voltage supply here. So here's the power transformer. A couple of bridge rectifiers here. These are the filter capacitors for the 2 power supplies. So let's go ahead and check the the transformer first. Switch this to AC. And looks like the red wires are 140 volts winding. Oh, there we go. 145. Okay, here's the 160 volt winding. Oh, sorry, 120 volt winding. Okay, so fortunately, power transformer seems to be okay. So let's go ahead and check for DC across this filter capacitor after the rectifiers. That's C503, which is right up here. Just back on DC. $168 volts. So rectifier is working fine. We've got, that means we've got DC here. This is reading very low. That's with respect to ground. So it looks like there's a very large voltage across this regulating transistor. But let's just check that. So we want to go from the negative of that capacitor to the 140 volt test point. Okay, there's the negative. There's the test point. So yeah, there's almost 300 volts across this regulating transistor. So that sort of suggests something wrong in this regulator circuit. And I think we'll just turn it off and start testing some components individually. Now, I guess we could somehow have a short up in the horizontal amplifier itself that would be bringing this 260 volts way down, but I don't think that's the case because all of the current is going through these two resistors, R838 and R839, so they'd at least be warm, and they're just stone cold. So I think the problem really is in the regulator here. So let's first just test these two transistors, Q501, the regulator, and then the driver for that. This is Q502. So 501 is NPN. Turn this to diode setting. And forward direction should be positive on the base. Okay, so base to emitter. That's good. Base to collector. And in reverse direction. Base to emitter, open. Base to collector, open. So power transistor looks okay. Let's look at this Q502, which is PNP. So negative on the base to the emitter, looks good. Base to collector, reverse direction, that's the emitter, that's the collector. So both those transistors look okay. So let's look at some of these resistors. Well, let's first do this little diode here. forward direction and reverse direction. Looks okay. So let's proceed to the resistors. Here, let's start with the low values. So 504 here, 100 ohms, 505, 510 ohms. And we'll do these in both directions in case they're bypassed by semiconductors. Okay, so this will be 504. Supposed to be 100. And in reverse direction. Same thing. Okay, so 505. Supposed to be 510. Looks good, reverse direction. Okay. Let's look at this voltage divider. That's 507, 100K, 508, 115K. That's 507. Well, that's low. Of course, it could have some circuit going around. And let's try this direction. This is supposed to be 100K. And it sort of looks like it's charging a capacitor or something, going asymptotically to 100K. Of course, we're mostly looking for readings that are too high rather than too low. So I think that's probably okay. Let's try 508, which is up here. Supposed to be 115. Again, that's reading a little low. Let's try the opposite. And it looks like that's kind of gradually going up to 115. Okay, let's try this 506, which is feeding the driver transistor. It's supposed to be 47K. And that's right here. Seems to be reading open. Let's try the other direction. Huh. Well, it's supposed to be 47K. And it's reading 47K, but only in one direction. Let's see if I've got these connections. I'm going to use some clip leads instead here. Maybe I just didn't get that connection on well. Okay, so there's one direction. 47. Reverse direction opens circuit. So I don't know, it seems like that resistor is open, and just coincidentally, when you read it in reverse, it finds a path through the circuitry that just happens to come out to 47K. Well, let's just take a look at what would happen if this resistor went open. Okay, so I think the way that this regulator works is that this transistor is monitoring the voltage at this point, which is on a voltage divider between the 260 and the ground. If you do the math, turns out this point, when this is 260, is going to be at 139 volts. And then over here we have this resistor draining through a diode here just above the 140 volt line. Of course, this is going to be more positive than the 140 volt line because of this DC supply. So this is going to be just above 140. This is 139. So you're going to get a small current through this Q502. That's going to turn it on. That allows current to go back this way through Q501, the regulating transistor. Going to turn that on, and then that's going to allow this current to flow, push this voltage up. When it reaches 260, let's say it goes a little bit above 260, that means this is going to be a little bit above 139, say 142. That means this current is going to stop. That's going to turn off the regulating transistor, bring the voltage back down. So I think in practice, what happens is that this is always partially conducting. This transistor is always partially conducting just enough voltage drop across it to make this 260 volts. So here's our suspect resistor, and of course what's going to happen, this becomes open, you get no current flowing here, this turns off, and you get a big voltage drop across Q501. Of course you have a load on here, so that can bring this way down to 24 volts as we saw, and no flow through here. I guess you're getting some flow through this R504 100K resistor, but of course that's not nearly enough to power this, so this is falling way down. So in other words, the symptoms that we see are consistent with an open R506. So let's just patch in another resistor there and see what it does. Okay, we're back on. I've still got the clip leads there from the test. Here's a 47K. Let's put it on. And there it goes. So it looks like that really was the problem. So we've just got to put a resistor in there. Now the question is, should I take this circuit board out or just try to patch it on the top? Now there's a lot of stuff to disconnect here. There's 3 knobs, 3 shafts that have got to be loosened. I think there's 8 connections. Some of them, the plug isn't even visible. So I think I'll at least try to just patch this on top and see how that goes. If it doesn't work well, I can always take the circuit board off and put it in from the bottom. Okay, so if you can see there, I've cut out R506, leaving the leads as long as I can, which is not very long, especially on the right side there. So I'm just going to try to tack a resistor on there. And what I've done here is use a slightly wider piece of wire and wrap the lead of this into a little curlicue there. So I'm going to drop that down on the short lead. I'll then try to wrap the other lead around the longer old resistor lead, and then try to solder it in. Okay, so I've got the new resistor pretty well wrapped around the leads, the old resistor leads, and just have to see if I can solder that in without melting something else. Okay, there it is, and I think I got it soldered in pretty well on both sides. Well, let's just check the connections here. So we want to measure the resistor by going to a site that we know is connected to it. So we want to go from the anode of this diode to the 260 volt test point. Okay, so here's the test point. Here's the diode in this direction. 30 and rising. Measure in the other direction. 47. So I think we got it connected in time to just try the scope. Okay, let's turn it on. Great, seems to be sweeping. Let's give it a signal here. Looks pretty good. So I think it's time to just put this back together. Okay, let's get this back together. So I think the key here is you get this back on first. And then you can kind of use the weight of the instrument. To fit the front over the middle case. Now all the screws seem to be lined up. Okay, we're ready for a final test here. Let's turn it on. Seems to still be sweeping. Got a little signal generator here, so let's give it a signal. Looks good. One feature I wasn't aware of is it has a 10x x-axis expander that can increase the time scale from like half a microsecond per division to 0.05 microseconds per division. So let's just try that. Let's give this a higher frequency. This goes up to 20. Megahertz. It's a good bit weaker signal. So let's crank this up to 20. Okay, so that's 20 megahertz on half a microsecond per division. Let's try the X expansion. And there it is. Turn off some lights here. So there it is, 20 megahertz, 1 cycle per division with 0.05 microseconds per division. So working pretty good now. This is a pretty nice instrument, and the one thing I really like about it is it's so serviceable. The service manual is available online for free. All the components are nicely set out and labeled, and it's all through hole components. None of this surface mount stuff. So that's it, and thanks for watching.